roads. We're back down in the dungeon, and we're continuing our skateboard press project. And we're going to take it today from a mechanical press to a machine that will let us compress our boards and mold our boards at the push of a button, or more accurately, at the flipping switch. We've got a bunch of components here that are going to let us apply power to the jacks that we're using as our driving forces for the press. And let me walk you through them. From the wall, we've got a power switch, we've got a power source, a 12 volt 30 amp power source. I hope that's going to be enough for what we need. We've got a speed controller that's got a similar set of ratings, and then we've got two windshield wiper motors, which are a really inexpensive way to get a lot of torque for not a lot of money. And we're going to wire this all up. And that's the secondary goal. The first goal is to not electrocute myself. I'm a little afraid of that. So we got some red and black. And we're going to just, without putting these things in any housing, we're going to get all of the components in line and see if we can get power to the motors and control their speed, plug it into the wall, and not electrocute myself. So let's get to it. Man, I feel like Tim Allen in The Santa Claus when he's like, what if I fall off the roof? What if I electrocute myself? There we go. Crimp that down. So each one of these components kindly has some instructions, but some of the instructions are a little bit more clear than the others. And I am just really hoping that red is positive and blue is neutral. I've never really seen blue used that way before, and the little pamphlet doesn't say anything about it, so fingers crossed, I guess. Pop that guy open. The instructions, the power source, are much better, and they're even in color. How nice is that? We've got input all the way on the right. L. N's gotta be for neutral. L for live. Cool. Alright. Maybe. Neutral. What do you think? Blue? I hope so. That's our live. That's our neutral. And my personal favorite, ground. The plug bone's connected to the power bone. Power bone's connected to the speed bone. Speed bone's connected to the motor bones. None of these things are actually bones. Okay. Oh my god, it's plugged in. Gloves. Okay, no dice there. Oh! Woo! How fast is this going? Pretty fast. Reverse. Yeah, baby! It lives! It lives, and I'm not getting electrocuted. Everything's grounded? Yeah, awesome. Okay, so the next step is to build a really good home for all of those electronic components to live in, so that we don't have mains exposed, and to get the power down to where we need it on the jacks. So, let's get to it! Okay, moment of truth. Yeah! Press goes up. Oh wait though. Oh wait though. Oh wait. Press goes down. Sweet. Whoops. Something a little weird there. So I moved the press for the first time, and 5 minutes later, I broke it. The linkage that I was using to connect the jacks to the windshield wiper motors were just these standard 7/8 socket wrenches, and I'm literally trying to fit a round peg in a square hole, and the hole's a little bit bigger than the shaft on the motors is. So what I did initially was shim them with a piece of sheet steel and then crank down the screw with a locking washer in hopes that that would be enough, but that almost immediately stripped out. After that, I figured I would try to drill through the sockets and then thread the holes so that I could add a set screw, which would hopefully keep the sockets in place. But the sockets appear to be stainless steel, and the problem with stainless steel is that it work hardens. It was almost impossible to drill through them, and then when I went to go cut the threads after a lot of work, I broke my tab. So that obviously wasn't working. I had about had enough, and it was time to bring out the big guns. I mocked up the exact linkage that I needed in Fusion 360 and sent it to Shapeways to be printed in metal. And man, that is really cool. These are really nice parts. They're solid metal, they're heavy. The layer lines are barely noticeable. This makes me want a metal printer, to be honest. I know I couldn't afford one, but hell if that's not cool. So what I have to do to make this work is I have to tap these holes so I can get a set screw in place, and I'm going to either file or drill a flat into the shank on the windshield wiper motors, and that way the set screw will have something to rest against. And after I do that, I am still going to use the screw on the inside of these parts because I left space for that as well. And that should lock it up, cinch it up real tight, and we shouldn't have a problem after that. Oh my god, that's so much easier than the stainless was. So much easier than the stainless. Cool. It's pretty flat. I don't know how flat it needs to be. Victory! Championship! We got a working skateboard press. The mold that's in here right now is a prototype mountain board mold that I made, and it is a real stress test for this press. It's almost the full build volume, and it has some really aggressive curves in it. On top of that, the material that I loaded it with is 1/8 inch Baltic birch, and it's 3 sheets of it. I would never really need to press that kind of material that way. That was just something I was doing to really push it to its limits and see what it was capable of. And the fact that it pretty much worked is a really good indication that this thing is going to be powerful enough to do everything we need it to do. So I'm over the moon. We built a press, and it works. The next step is we got to make some molds. So I'm going to be revisiting the 3D printed mold experiment, and from there we're going to make some skateboards. So thanks for sticking along with me for the journey. It's been a real fun one. I've enjoyed getting to share this with you, and stick around for more fun projects in the future. I'll see you soon. Turn this little bit around. There we go. Turn this mother out.